Alright, this is a video recording to go over the exam from last semester. This is the actual exam from last semester. So let's take a look at question number 1 first. Question number 1 is this one here. It does not involve the use of structures, so it is pretty much fair to be asked this semester as well, but you know that it's not going to be the same question. If you enter, so I'm just reading out the question here. If you enter your 7-digit student ID, and when I ask for your 7-digit student ID, it means without the W and just the 7 digits. As the input to the standard input file, what is the output of the following program? So it is asking you to track all of the printf statements, like this one here, this one here, this one here, and so on. And we want to know what the program is going to output. The way to do this is, well, there are 2 ways to do it. First way is to actually mechanically follow the code like the computer and figure out what the program is actually going to do. The second way is to analyze the program so that you can figure out what the subroutine is actually doing, and then reason out what the program is going to do. Alright, so let me see if I can open up a terminal that has a larger font set. There we go. Okay, this one is better. So what we want to do is to first of all, let's go ahead and analyze the subroutine. The main program doesn't do much, because all it does is to print x open and close paren is %d, and %d is the placeholder for the integer value of the invocation of x as a subroutine. So the bottom line is you have to analyze the code of function x to find out what it does. So let's go ahead and analyze this step by step. First line is the first thing it does is scanf. %c is the format string reading into ch, which is a character variable, the address of ch. So it's basically just attempting to read a character, but the return value of scanf indicates the number of items that it was able to read. So in this case, it's usually 1. It can be -1, but it should not be 0, because everything is interpreted as characters. And here's a uninitialized local variable result. So right here we have a condition in a conditional statement. So let's take a look at this one. If r is less than 1, which means we could not read the character, or ch is less than the ASCII code of 0, or ch is greater than the ASCII code of 9. So that means if we did not read anything, or what we read is not a digit, then we perform the following logic. The following logic is quite simple. The first thing we do is to indicate result is 0, and then the second one is to print end with a line feed character. And after the conditional statement, we go straight to the return statement. So that means the then case of the conditional statement is the one that does not do the recursion. Else, okay, this is the else branch of the conditional statement. This one does go for the recursion, but before it does go for the recursion, it will print processing D, and that is going to be the integer value of the digit that we just read, because we are subtracting the ASCII code of 0 from the character that we just read into, and then the next line is the one that does the recursion, because you can see that x is called here as a part of the recursion here. So we take the value of return value of x, or the invocation of x, multiply that by 10, and then we have to add the character that I just read, and subtract the ASCII code of 0 from it to get the actual value of the digit. Multiply that by 3 and then mod 10. So that means we have to do a little bit of calculation, and then we print result equals 2 %d, which is result here. So the way I'm going to do this is to analyze the structure of the program instead of just blindly following the code, because following the code sometimes can take longer, and it's usually better to analyze the code to figure out what it does. Alright, so let's go ahead, let me see, find my terminal. Okay, I think that's my terminal here, and I'm going to change the text size so we zoom in, and one more time, there we go. Alright, so what we'll do is we are going to take a look at the character that we are going to read and what the program is going to do with it. So the first thing we will see as the output is not x open paren close paren is blah blah blah, because it won't get to this, it won't actually call the printf until x is done, until function x has returned. So this is not the actual first output. In fact, if you want to, you can indicate this as the end. This is the very last thing that should be printed. So the first thing that is actually going to be printed is either end or processing. But since we already know the file contains your 7-digit student ID, we know that it will be able to read at least 7 times successfully, and then the 8th time is something that we'll talk about. So the first thing it's going to do is it will read a character successfully. So right here I'm going to say your student ID is going to be some fake one. Yeah, so this is a fake student ID here. 1, 2, 3, 4, 5, 6, 7 digits. Alright, so the first digit it is reading in is 1, and it's going to fail this condition because R obviously is going to be exactly 1, and then CH is within the range of 1 and 0 and 9. And then down here, the first output is processing, and since we're just printing out the value of the digit itself, which is 1, so that's what the first output, and then it does the recursion. So the next time it will do the recursion is it will go call x again, and it's going to scan the digit 4 this time, and as you can probably imagine, it's going to say processing 4, and then processing 3, processing 8, processing 2, processing 9, processing 4. Now, in the iteration or in the invocation to process the last digit 4, it is going to call x again. But this time when it calls x, the scanf will be successful because it's going to read in the line feed character. The line feed character, unfortunately, is not in the range of the ASCII code of 0 to the ASCII code of 9, so it's going to skip that. Oh, excuse me, I take it back. It is actually going to get into this then branch because the line feed ASCII code is actually less than the ASCII code of 0. So it will have result equal to 0, and then it will end. So we'll see end here first. And then it goes back to the previous invocation where 4 is the digit to be processed. Okay? And since the function is returning 0, it is going to be 0 here times 10, which is also 0. And we already know what digit we are talking about. It is 4. 4 times 3 is 12. 12 mod 10 is 2. So result equals to 2, because we are storing this entire result back into the local variable result, and then we print it out using the printf statement. So it's going to print result equals 2. So that takes care of the last invocation. Now we're back to the second last invocation. So 2 is the return value of x. 2 times 10 is 20. And then we have this digit is 9. 9 times 3 is 27. 27 mod 10 is 7. So we have 27 as the entire sum here. So result equals to 27. Then we go back to process the 2. So now we have 270 plus 2 times 3 mod 10. 2 times 3 is 6. 6 mod 10 is still 6. So in this case, we have result equals to 276. And then if we go back to the invocation that processes 8, basically you can see that we are just multiplying this number by 10 and then plus the digit that we are processing. times 3 mod 10. So in this case, result is going to be 276, and then we can see that 8 times 3 is 24, 24 mod 10 is 4. And then the next one is going to be 2764. Oops, move the cursor. Okay. And this time we are processing the digit 3. 3 times 3 is 9. 9 mod 10 is 9. And then we are down to the second last digit, or I should say the second digit. So we have 27649, and then we have 4. 4 times 3 is 12. 12 mod 10 is 2. Now we are down to the first invocation of x, which is processing the digit 1. So now we have 27649, and then 1 times 3 is 3. 3 mod 10 is also 3. And this is the actual value returned all the way back to main. And as a result, main is going to print 2764923, and that's the actual output of this program. So I'm going to record the other questions next.